Welcome, class, to Lesson 8-9, day number 1 of a 2-day lesson. Today, strong mathematicians can decompose quadrilaterals and triangles into other figures. So you can take out your pencil, your notebook, write down today's date, and we'll just jump right in and begin. Here are the notes that we have that obviously have had a long time. Just a great review to get us acclimated to our lesson. Acute angles, remember, are 0 to 90. Obtuse angles are from 90 and 180. Right angles are exactly 90, and straight angles are exactly 180 degrees. Remember, a triangle has 3 sides. There could be a right triangle that has 1 right angle, which is shown by drawing a small square at the right angle. An obtuse triangle has 1 obtuse angle, and an acute triangle has 3 acute angles. And they also can be analyzed by their sides. Remember, equilateral triangle has 3 equal sides. An isosceles triangle has 2 equal sides. And a scalene triangle has 0 equal sides. As a good review because we're taking quadrilaterals and cutting them in half and figuring that out. Yesterday we wrote down this chart to help us out on what are quadrilaterals, parallelograms, rhombus, rectangles, squares, and trapezoids. There that chart is again if you need to reference it or to write down that material if you forgot it from yesterday. Also today, here's your new note that you want to add in. What is the diagonal of a quadrilateral? Well, it's a line segment that connects 2 opposite corners or vertices. You can make triangles by drawing a diagonal on a quadrilateral. So really there are 2 different opposite sides. We know each thing comes with opposite sides. So we know that right here, this is A, and this is B, and this is C, and this is D. Well, we know that A and B are opposite sides, and we know that C and D are opposite sides. So that means we're going to take this and go from one of these corners, from where A and C meets, and we are going to cut it in half this way. And now, in a sense, we form 2 different triangles. Or we can also cut it the other way, which would go from this direction, and we'd also make 2 triangles this way. Notice when you look at those triangles we've created now, they are not the same, they're different, and then we're going to be able to identify them by their angles and their sides, like we talked about in our introduction. So make sure you write down what diagonal of quadrilaterals means, and what it means to go from the 2 opposite corners. And right now we're going to dive right in. So it says list all the names for the quadrilateral, then use letters to name the triangles you make with the diagonals, and tell what kind of triangles they are. So really it's a kind of a 3-step process. So our first step we're going to look at what are the names. So list all of the names for the quadrilateral. So the first thing that comes to mind, boom, we see it, we think square. Which we know if it's a square, it also has the same traits as a rectangle. So this could also be classified as a rectangle. It can also be classified now as a parallelogram. Why? Because it has 4 sides and 2 opposite sides that are parallel of each other. And then it's a rectangle because it also has 4 right angles, and a square because it has 4 equal sides. So that's the first part. We identify that, but so that's what we would call it specifically, but each of these would still work for that shape. Now we're going to use the letters. So we're going to create those diagonals of the vertices. We're going to cut it right in half this way first. And now we need to name our triangles. So you always want to put, once we draw the line, the opposite side is going to be our vertex. So we have triangle CAB and triangle CDB. So notice where your line comes from. That's always going to be one of the ends and the other end, and then the opposite side becomes your middle point. So those, what kind of triangles did we draw? Well, if it's a square, we know that these are going to be right angles. So these are both right triangles. And this is also a right triangle. And now we're going to do the same thing. We're going to go from the other direction. Instead of going from C to B, we're going to make our lines from A to D to divide this in half. And now we're going to write our triangles. Remember, we're going to go whatever's the opposite letter goes into the middle. So we start with A, so we have ACD, and triangle ABD. And if we look, these same things that happened before, since we're a square, we know these are also right angles. So these would both be a right triangle and a right triangle. So notice the square is kind of a pretty straightforward shape. Well, no matter how we ever divide the square in half, From diagonals, we're going to get right triangles. Is that always the case? No, that's not always going to be the case, as you'll find out as we do some different quadrilaterals. So you can draw this other quadrilateral out. Looks like that we have a, can you name what this one is? Hopefully you came up with the right name. This name would be the rhombus. That would be the most specific name. What you know, a rhombus could also be a parallelogram because it has two sides of opposite sides parallel. Parallelogram. And now if we decide we want to cut this in half, so we'll make our first cut. We're going to go this way for our triangle. So we've got triangle HEF, because we're always going to the line. We go to the opposite ones in the middle. And triangle HGF. And if I look at those and I think about this line right here, this angle right there looks pretty big. So like this would be a right angle, and it's past that. So this would be an obtuse triangle. And the bottom one would also be an obtuse triangle. Does that mean the other ones are going to be obtuse triangles? Well, let's find out. So now we can cut from H to F, so we go from E to G. E to G with our cut in half. So now we look at this angle opposite, which would be the H and the F. So we got triangle EHG and triangle EFG. And if we look at both of those triangles, we see that those are smaller, and this would be like 90 degrees right here, so that'd be an acute triangle. And it looks like the same holds true, like this would be 90, so we're not quite there, so we have another acute triangle. So you can pause the video right now and write down this information to help you out. So now we said we're going to make a quadrilateral by joining the equal sides of two triangles that are the same size and shape. You want to draw what the quadrilateral would look like if you put the following lines together. So if you have a piece of computer paper and you just want to cut it from one diagonal to the other, so give you exactly two of the same triangles I have, you can label these parts A, B, and C, A, B, and C, and we're going to do the first one together on the screen. So what I want to do is, what if AB is joined with AB? What kind of quadrilateral would it look like? Well, let's find out. So if we take our pointer, we have the first shape right here, and now we're going to take A and B. So here's our line. So we're going to take this one. We're going to have to spin it. We'll go spin it this way to be like this. We'll take this A and B. We'll put it right there. Now you're going to notice that A and B don't necessarily match. Like this isn't A to A, and this isn't B to B. Like A and A aren't right here, and B to B aren't right there. But that's okay because this is line AB right here, and this is line AB, and those two lines are touching. So now we have to look at this shape that we created, this outside shape. It looks like we have created by that shape, it looks like if we join AB and AB together, we have a parallelogram. So do we have a rhombus? Do we have four equal sides? Nope, so we don't have a rhombus. Do we have four right angles? Nope, we don't have four right angles, so it can't be a rectangle or a square. So obviously the only thing that when we join AB and AB together is we have a parallelogram. So you're going to cheat a chance with your pieces of paper and box through your examples to put those pieces of paper together and show me what shapes created when you put those together. So hang on to those pieces of paper you made. And now we're going to name the triangle that is used twice to form each of the following quadrilaterals. What kind of triangle is it? And then list all the names for the quadrilateral. So if we take a look at it, these are our lists. We got V, W, X, Y, Z. They might be a little blurry, and I apologize for that. So you have to figure out which one of those shapes made our quadrilateral. And if I'm looking right here, if I think about this shape, it looks like it's kind of, if I think about triangles, right? It looks like it's kind of an obtuse triangle. This line looks obtuse right here. So that means I know we can get rid of this one. So this one's gone. Looks like these are all acute angles. So this one's gone. This is all gone. This one's only got a right angle. So it looks like the only one that has obtuse angles would be letter Z. So it looks like we have an obtuse. And if you think about the side lengths, I'm thinking these sides, it looks like they're all different sizes. So that would be a scalene triangle. Is the shape that's what created this quadrilateral. What would be the name of this quadrilateral? Well, I think right away the first thing that jumps up is parallelogram. Which means I got some other choices of rhombus, but sides don't look equal. So it also eliminated a square as well, because square has equal sides. And it doesn't have right angles, so it eliminated a rectangle. So it looks like this name for this quadrilateral, the only name I can have for it is a parallelogram. So you can pause the video now and write down this information to help you out as well. And now it is your turn. So hopefully take some really good notes to help you out breaking this down. So draw a big line on your paper, write box 3, now your turn. And the 3 parts what you do, so you can draw the shape 3 times and you'll label it. Remember the first part that we did is we named all the names for the quadrilateral. Then we went through the diagonals. We named one of the diagonals with one color and the triangles. And then we did the same thing going the other direction with the diagonals and what kind of triangles they were. So you need to go back and watch the video or look back at your notes to help you out. By all means, pause the video and go do that right now. Here's another example, those same skills. I want you to list, so draw the shape 3 times, list the name for all the quadrilaterals, and then tell me what triangles they make when you cut them in opposite directions. Good luck. And now that we've joined A and B together, hopefully you have those big pieces of paper left that you can put them together and show me what does BC look like when you join it, and what do AC look like when you join it, and what shape do they make. I'm excited to see you put these pieces of paper together. If you take a photo and submit that as well, that'd be great so I can see you manipulating your manipulatives. And also there's a couple right now. We got that piece right now. So which one made up that drawing? Was it V, triangle Y, X, W, X, Y, Z? Good luck. If you have any questions, comments, or concerns, feel free to write them down or share them out. If you have any strategies you use, make sure you share those as well. And once again, thank you very much for another great lesson.